Okay, welcome to our YouTube channel. This is sixth video in gender prediction tutorial series using machine learning. Just to remind you of what we covered in our previous tutorial. In our previous tutorial, we learned how to train test split, thus how we can divide our data set into two groups. First group for training a logarithm, and the second group for testing a logarithm. Then we learned how to fit the model, which is to train a logarithm by giving it the dataset. So in this video, we are going to learn accuracy measure. Accuracy measure means we want to determine the accuracy performance of our algorithm we used to train it with the dataset. Our algorithm we used to train dataset is Multinomial Naive Bayes. So we are going to check its performance. In machine learning, there are different metrics, which are the measures for performance measures for algorithm. There is cross validation, there is precision, there is a recall, there is F1 score and the confusion matrix. But for our case, we are going to determine the performance of our algorithm by using confusion matrix, F1 score, precision, and recall. So here we are going to start to learn the meaning of cross validation. Then after we will learn why do we need cross validation. Finally, we will go to our third part on how to cross validate. So cross validation means splitting train set into k-folds. Thus the group making prediction and evaluating by counting the total number of correction. Let's say we have our data set. So by using cross validation, it divides our data set into a certain type or a certain number of groups. Let's say 5 groups. It is split our data set into small 5 groups. Then train a logarithm by using those 4 groups, making prediction and counting the total number of correct prediction. That's the meaning of cross validation. It is split the dataset into small subgroups, make training to algorithm, predict and count the total number of correct prediction. Why do we need cross validation? We need cross validation because it is one of the best accuracy measure in machine learning, because it makes the training and the prediction of dataset into several times into smaller groups. So after training those groups, it count the total number of correct prediction. Then you can use the mean or the average of accuracy for oral accuracy. You have got maybe 5 times. So cross validation is considered as one of best metric in machine learning. So our third part of this video is how to make a cross validation. So let me learn this cell from the beginning up to restart and learn all. Yes, I want to run all of these cells so as we can easily scale on. Yes, this is gender prediction tutorial series using machine learning. This is machine learning. Alright. Okay, so far so nice. So this is cross validation. I'm putting comment cross validation. Yes. So here I need to import cross validation. So from sklen dot model dot model selection import cross val score. Yes, from sklen dot model selection import cross val score. Then v is equal cross val score. Then brackets classification, which is multinomial naive Bayes X-train group for training algorithm, and a y-train, yeah, then CV is equal to 10. When we say CV is equal to 10, let me give a short explanation of parameters we have passed inside the cross-val score. This is algorithm, which is multinomial naive Bayes. This is training, X-train, because the training set of our data set have X features and Y features. So this is X features for training data set, and this is Y feature for training our data set. CV is equal to 10 means it will cross validate 10 times. So it will divide your data set into 10 minor group, then it train them, make a prediction, and count the total number of correction. So for I in range, 10, yes. For I in range 10, print accuracy of naive Bayes is something like this. The accuracy of naive Bayes is here. We need we want to make some format in Python, then to percentage. We need it to output only 2 decimal points. Okay, that's it. Now after we need to put something like this, here dot format, if I'm not mistaken, dot format, then brackets v square brackets I, something like this, print, want to print empty line, then we will need to print the average of all accuracy, I mean average of 10 accuracy cross validated. So let me say the mean accuracy of naive Bayes is the mean accuracy of naive Bayes is v dot mean. So this will print the mean accuracy of cross validation. Let me run this cell and see what happens. So as you can see, accuracy of naive Bayes is 69.15, 69. Then the mean accuracy of cross validation is 69. Yeah, 69 almost. It's 69%. But here, the accuracy of the normal accuracy of our logarithm was 70%. So this is cross validation. We have learned the meaning of cross validation. cross-validate 10 times by dividing data set into 10 or several number of groups, training them, make a prediction, and count the total number of correction. Then we have learned why do we need cross-validation. So that's the end of our first part of this video. So our last part of this video is to find the accuracy by using precision, by using recall and the F1 score. So in our last part of this video, we are going to learn the meaning of F1 score, the meaning of precision, meaning of recall, why do we need them, and how to do. So just by definition, recall is the ability of classifier to find all positive instance. Means when we say recall, means is the ability of classifier to make positive, means to 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 make a correct prediction by a few words. High recall indicates class is correctly recognized. That is how recall is ability of classifier to find all positive instance. So precision is the ability of classifier not to label an instance positive that is actually negative. When we say precision, we mean that is ability of classifier not to label an instance positive that is actually negative. Let's say we are predicting if a fruit is an apple or not apple. So when you come across precision, it means the ability of classifier not to label other fruits like oranges, lemon, tomato as an apple while they are not apple. So in short, I can say precision is the ability of classifier not to make to make a wrong prediction. So that is precision. F1 score is the harmonic meaning of precision and recall. When we say F1 score, means we take the accuracy of precision and accuracy of recall, divide them and find their meaning. So that's it. Here we are going to measure the performance of Multinomial Naive Bayes using classification report, where we will get precision, we'll get recall and F1 score. So here let me write recall, precision, and F1 score. That's it. So as I have said that recall is equal to true positive divide true positive plus false negative. That's a formula for recall. Formula for precision is equal to true positive plus false positive. So that's it. So before we needed to display recall, precision, and F1 score, let me import classifier or classification report from sklearn. So from sklearn dot matrix import classification report. Classification report will print out precision, recall, and F1 score. So let's print print classification underscore report. So here let me do something here. Predict is equal to fit dot is fit dot predict, if I'm not mistaken. Predict, then x underscore test, something like this, if I'm not wrong. So classification report, we pass y test predict rebels is equal to let me 1 2 hope 3, something like this. Let's see if we can print out. Oops, fit is not defined. What's wrong? Let me do something like this. It should be something like this. I hope something like this. Oops, what's happening? Let me see something. Let me see something here. Let me see something about our classification report. Classification report. Oops. Yeah, I forgot this line. Fit is equal to classification dot fit. Yes, that's why there is some errors. Fit is equal to classification dot fit, then here fit dot predict bracket xt test. So let me run this cell once again. So this is this is precision of 95%, or recall is very low, 0.5, which is 25%, and the F1 score is 39%. So yeah, this is how we can determine the accuracy. We can determine the accuracy of algorithm by using precision, recall, and F1 score. So that's it. I just want to say this is the end of our sixth video in gender prediction tutorial series using machine learning. Just to put a short summary of what we have covered, we learned the meaning of cross-validation, why we need cross-validation, and how to do. Also, we learned what the meaning of recall, precision, and F1 score, and how to find recall, precision, and F1 score using classification report from sklearn.metrics. So this is an end of our sixth video of gender prediction tutorial series using machine learning. In our seventh video, we'll learn how to develop or how to create a model and dump it in disk by using joblib. So do not miss our next YouTube tutorial. There are some more to come. Don't forget to like, put comment, and subscribe for next video updates. Goodbye.